3, 2, 1.
Hello! In this video of practical tips for rocket engineering, we're going to be talking about panels, our gas and fluid propellant panels, propellant and oxidizer panels, and some of the things that we might want to consider when using them. So first of all, it's really important to be really clear with your propellant panels, knowing exactly where the pressure and where the gases are going at any one time. And to help you with that, you really want to be very clear with how your panel is laid out. For example, notice that all of our valves, pressure relief valves, and all the other gauges and sensors are clearly labelled. For instance, G1 for our gauge number 1, V1 being our valve number 1, V6 being our solenoid valve, our V3 being our relief valve number 3. So whenever I communicate or write my procedures, and in them I might say open valve 1, close valve 2, it is very clear and evident which valves I am talking about at any one time. You also notice on our panels is that there is clear directions for where the gases are coming through and around our system. So we know which directions we're expecting the flows of these fluids and gases to be at any one time. So we have our propellants coming in from our gas cage, down through our lines, all at high pressure, coming into our regulator. So up until this point, our pressure is at bottle pressure, which could be up to 300 bar. So the pressure is then regulated down and then goes through our system. And in this case, we've got a number of valves in place. So at the regulator, the pressure gets regulated down and then will go through our system. So in this case, a normal procedure for our propellant valve to go through is a regulator. Now, although not shown on this particular flow diagram, there's actually a filter before it goes into the regulator. So it comes through into a filter, into our pressure regulator, through our first valve. Notice that on all of these valves, these are not ball valves, these are all metered valves, okay, which allows us to be a bit more flexible with what types of propellants that we put through this system. The working fluid or gas will come through our system. Now, if we were to open this particular valve, V2, it would go up and vent. Okay, so this one will remain closed during normal operations, and then it will go through the gauge and then through this, a slightly complicated affair, but we use this to pressurize a separate pressure container if required. But in normal operations, the gas would come through our gas lines, up through here, through our safety solenoid valve, which although it's here on the picture, is actually up here and is our Rotork safety valve. And then it will come back down into the system. It will flow through the pipe, through our flow sensors, and then off into the chamber. Now notice that we've got a few things in place, okay? So first of all, I mentioned before about the vent valve. So we've got a vent valve here to be able to vent this half of the pressure panel. And we've got a second vent valve, which will be able to vent on the other side of the solenoid valve. So if we needed to, and the solenoid valve was closed, we would be able to depressurize the system by going through either one of these vent lines and out into the open. So what you'll notice is that we have two sets of relief valves, and they will be set at a pressure for this particular panel. Now, in this case, we have set RV1 and RV2 at 31 bar, and we've set RV2 and RV4 at 32 bar. The idea being is that if RV1 or RV3 fail to open, then we have backup relief valves as well. So when putting a pressure panel together like this, you need to think about some of the basics first. Where is the panel actually going to be mounted? Have you done all the correct paperwork? If you're unsure of the regulations that you need to conform to, then look at the PSSR regulations, and specifically for pressure assembly equipment, which is in permanent use, you also need to think about stuff like the written scheme of examinations. Okay, please consult with your local health and safety manager or the HSE for more details on that. So as well as the regulations and being mounted in a position which works for your test facility, you need to think about the flow of the gases and the fluids going through the system. You need to be able to vent different parts of the system, and you need to protect your components from overpressurization. You might additionally want to think of putting some additional sensors in here. For instance, we have put a flow meter in line so we can measure the rate of flow of the gas or fluid going through the system. You might want to think about putting additional pressure sensors or temperature sensors in and around your system as well. So with the propellant panel, you can see that a lot of the pipe work here is stainless steel. When you're dealing with oxygen specifically and other types of oxidizers, you might need to use copper and brass fittings. Although these panels on the outside look similar, behind them you need to think very carefully of the materials that you're going to use. So here we've had a quick look at the panels that we use at this facility. Hopefully they've inspired you, and if you like this video then please like and subscribe.